Hello, pre-cal students. This is the Module 2 practice test. Good stuff. Let's get started on it. All right, the first thing we have is find the vertex of the graph of the function. Well, fortunately, they gave this to us in vertex form, right? So vertex form is x minus h squared plus k, which means the vertex is hk. So x minus the h, x minus the 5, so 5, and the k is 10. They're both positive, so 5, 10. All right, moving on. Find the vertex of this one. Now, this one they did not give to us in vertex form, so we're going to have to complete the square and find that. So the first thing, let's go ahead and factor a 3 out. X squared minus 6x plus 6. Oh, 8. Let's do math correctly while we're doing it. Factor out a 3, that leaves a negative 6 and an 8. So from this, let's convert this to vertex form. And we'll do that by completing the square. So if we complete the square, we take half of this, right? Negative 6 becomes negative 3, and we square it. So we would be adding a 9, which means we also need to subtract a 9, and we still have that plus 8 out there. All right, so it breaks out like that. And so this becomes x minus 3 squared. We still have a 3 out front officially. And this is minus 1. So we also got to remember we've got this 3 out there that is going to affect our final answer. So when we multiply it back in, it's going to be a minus 3 right there. So with our vertex form, it's going to be 3, negative 3, because we did have this factor out front. And we could have left it in at the beginning and just dealt with what we wanted, but it's a little tricky when you have this 3x squared. You can't factor the square in there. That's why we pulled it out. But we have to remember it is being multiplied by everything inside. So when we end up with this minus 1, it's still being affected by the 3 out there. And this is too, but the vertex form does allow us to pull out the h for our vertex. So 3, negative 3 is the answer we're looking for right there. All right, let's find the axis of the graph of this function. All right, well, this is very similar to our last one, but this time we're going to factor it a little differently. This time we're going to pull a 4 out, but only out of the x squared plus 2x portion, and we're going to leave the plus 7 by itself. We're not factoring a 4 out of that. We can't. But if we put it in vertex form again, if this is the vertex, then if that's the vertex, then this is the axis, right? That is the axis of symmetry, is whatever the x is. So we just need to get this in vertex form. So again, we can find the axis of symmetry. So this time, we cut this in half. It's going to be a minus 1x, right? So we got 4 times x squared plus 2x minus 1 squared, be a plus 1, and then we subtract 1, and we have the plus 7. So this becomes x plus 1 squared minus 1. All of that still being affected by the 4 plus 7. So when we want to combine these to get what number is k for that, not that we need it, because we know that if it's x plus 1, if it's x plus 1 and it's supposed to be a minus, we know that's actually a minus 1 is what the h is. So that is going to be our axis. But when we wanted to figure out the entire vertex, we'd have to multiply 4. It'd be a minus 4 that we put to that. So it'd be a plus 3 would be the vertex of that. But we just need on this one to find the axis, which is the x of the vertex. All right. Let's continue. Write the quadratic function in vertex form. All right, here's another one. This was just straightforward. We don't have to factor anything out. So let's just complete the square here. So we cut that in half, make it a 2, and we square it. So we add a 4, and that will make that a perfect square, which means we also have to subtract the 4, and we still have the 7 out there at the end. So we add 4, subtract 4. This becomes x plus 2 squared, and then we have a plus 3. So we're looking for x plus 2 squared plus 3 right there. All right, a projectile is thrown upward, so its distance above the ground after t seconds is h equals negative 16t squared plus 672t. After how many seconds does it reach its maximum height, right? So that, again, would be the vertex if we were graphing it, right? What is the vertex? And the seconds would be the x part of that. The y would be the maximum height. So, again, we just need to find the x coordinate for this equation for the vertex. So let's take this and factor out the negative 16, which will leave us t squared plus, let's see, my trusty calculator here, and take 672, pardon me, 672 divided by negative 16, and that's minus 42. So I need to subtract that. Minus 42. So 42 times negative 16 gives us like 672. Okay, so that is after factored out. So now we need to complete the square. So we got negative 16 out here. T squared minus, there's still a t there. There is still a t. Almost forgot my t. Minus 42t. This would be a negative 21 when we cut that in half, and square 21 times 21, which is, let's see, be 441. Is that right? 21 times 21, 441. So it'd be plus 441 minus 441. Right, so when we take this part, negative 16, t squared minus 21 squared, t minus 21 squared, and then we still have the minus 441 out there. That's all we need to know. 21 seconds. If this is t minus 21, that's the same as the x minus h. 21 seconds is the x coordinate of the vertex. Don't need the y because it's just asking for seconds. 21 seconds. All right, let's move on to something a little different out of the vertex form. Find the zeros of this function. Find the zeros. All right, so we need to factor this. All right, so the first thing we see is every term has a 3 and an x that we can factor out. So if we set it equal to 0 and factor out as small as we can, so if we factor out 3x, that leaves x squared for the first term, negative 4x for the second term, and factor a 3x out of that leaves negative 5. Okay, so now we've got just a quadratic, which we can factor. You can use the quadratic formula, or if you can factor that into 2 binomials, we can do that way. I'm going to choose just to factor it. Negative 5 would be negative 5 and 1, or 1 and negative 5. That's only 2, but I need a negative middle term. So this is going to be x minus 5, x plus 1. Okay, so what are the zeros? If this all equals 0, that means 3x equals 0, right? If 3x equals 0, then x equals 0. If x minus 5 equals 0, then x equals 5. And if x plus 1 equals 0, x equals negative 1. So there are the 3 zeros. 0, negative 1, and 5 right there. So that's just a factoring. We started with a power to 3. We got it down to a quadratic, and then we just factored it down. All right, find the zeros of this polynomial function and state the multiplicity of each. So the zeros. So if it's x, if we multiply these together and it ends up 0, that means one of these has to be a 0. If it's x plus 8 equal to 0, then that's when x equals -8, right? Subtract 8 from both sides. And how many? There are 2 of those. There are 2 zeros at -8. So -8 has a multiplicity of 2. That's the only one that has that one, so it's got to be that. And +8 has a multiplicity of 3. -8, multiplicity 2, +8, multiplicity 3. So there are 5 zeros there, but they are repeating zeros. Repeating zeros. Okay. Let's move on to number 5. Find a cubic function with these zeros. And we have the square root of 7, we have negative square root of 7, and we have -4. So if that's the zeros, then we would write the factors as x minus the square root of 7. That would be one factor for square root of 7 to be a 0. The next one would be a negative, so that means it's a x plus the square root of 7 would be a factor. And then if -4 is one of the zeros, x plus 4 would be one of the factors. So that's the 3 factors that we multiply together that would have these 3 zeros, right? -4 plus 4 is 0, so that's one of them. Negative square root of 7 plus the square root of 7 is 0, and square root of 7 minus square root of 7. So we just have to do the math to combine all of these. So let's multiply these two together first. X times x is x squared, and then distributing x plus the square root of 7 x's. Now let's distribute this, negative square root of 7 x's. And negative square root of 7 times positive square root of 7 would be positive times a negative. And square root of 7 times square root of 7 is just 7. All right. And then we still have x plus 4 over here. So let's simplify this. Plus square root of 7 x's, negative square root of 7 x's, those cancel each other out. So we have x squared minus 7 times x plus 4. Let's multiply this out. Distribute x squared to both of those. That would be x to the third minus 4x squared. And distribute the -7 minus 7x minus 28. There are no like terms, so that should be our final answer. So which one is that? X to the third plus 4, nope, plus 4, nope, minus 4x minus 7x minus 28. It's our third choice right there. That's the only one that has all negatives after the first term. All right, use synthetic division. Write a summary statement in fraction form. So if we divide the numerator by the denominator, we should get one of these answers. Now remember, synthetic division, we can do that if it's an x minus 2 or an x plus 2 or something, as long as it's just a simple linear binomial there. So if it's x minus 2, we're going to use the positive 2. Remember, we use the opposite sign, because if that was equal to 0, 2 minus 2. So if we divide that in there, we just need the coefficients, -3, -5, 4. Least in space, the first term comes straight down. 2 times 2 is 4. -3 plus 4 is +1. 2 times 1 is 2. -5 plus 2 is -3. 2 times -3 is -6. Add those together, we get -2. So that means our answer, this was a third degree term, so this is a second degree term. And that's actually the second degree. This will be x to the first degree, and the coefficient is just 1. And then this will be the constant. And we have a remainder of -2. And we divided it by x minus 2. So it's -2 x minus 2's left over. So plus x plus, these both have plus x. This is the one that has -3 and the remainder of 2. This one matches exactly. Perfect. We'll take that one. We'll take that one right there. Use the rational zeros theorem to write a list of all potential rational zeros. All right, so this is where we take the constant, okay, 24, and we figure out what are all the possible combinations of numbers we can multiply together. What are all the factors of 24? We got 1 and 24. We have 2 and 12. We have 3 times 8. I'm trying to list them in order without running out of space. We have 4 times 6. And that's it. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And then the bottom of the fraction would be coefficient of 1. That's it. So 1 over 1. So here are the possible ones. 1 over 1 would just be, it could be a positive or a negative. Remember, it could be a positive or a negative. Plus or minus 1, 2. So these are, since these are all over 1, it's just all of these numbers plus or minus. So minus 3, plus or minus 4. If this was a 2, we'd have to do 1/2 and 1, 2 over 2 is 1, 3/2, anything. If we had more options down here, if this was a 1 and a 2, then we'd have to have the list to be twice as long. But since it's just all of these numbers, looks like this one, 1, 2, 3, 4, 6, 8, 12, 24. That's our numbers, all plus or minus. That's our possible rational zeros, right? Has to be from that list. Okay, write this expression in standard form. Well, standard form would not have this imaginary number as a denominator. So we have to multiply this by 1. And let's talk about what that 1 is going to look like. I'm going to multiply it by 1, and here's what my 1 is. 4 plus 13i over 4 plus 13i. That's 1, right? Anything divided by itself is 1. So my 1 is going to look like that. And if I multiply this by 1, I'm not changing the value of it, right? So that's how we change things. We multiply them by 1, and we get to choose what that 1 looks like. All right, so the top would be 6 times 4, 24, and 6 times 13i, which would be plus 78. Again, let's do the math correctly while we're doing this. 78i. Okay, that is our numerator. The denominator would be 4. Got to distribute because this is 2 binomials, really. Right? So 4 times 4 is 16. And then we got 4 times 13i. So that's 52i. And then we have negative 13 times 4. So negative 52i. And then negative 13i times positive 13i. So that makes it negative 169i squared. Right? 13i times negative 13i, negative 169i squared. So let's simplify this. So on top, we cannot do anything with that. That's as simple as it gets. Right? We have a real portion and an imaginary portion. Now on the bottom, we have 16 plus 52i minus 52i, those zero out. And then negative 169i squared. I squared is the same thing as negative 1. So this is negative 169 times negative 1, or positive 169. All right, so this will simplify to be 169 plus 16, 185. And the top is 24 plus 78i. Now, they break it out into separate fractions, so we can do that 24 over 185 plus 78i over 185. So we have our real number and our imaginary number with a plus. These are both negative. Ours is not a negative, so ours has to be one of these two. It's this one right here, 24 185 over 78 185's I. There we go. Okay, more fun. Oh, this looks like it's going to be there's going to be some work here maybe, right? Write a polynomial function of minimum degree with real coefficients whose zeros include these listed right here. And write it in standard form. So from largest exponent to smallest. All right, we got some work to do. So if 4 is one of the zeros, that means x minus 4 is one of our factors. If negative 14, that means x plus 14 is one of our factors. This is x minus parentheses 5 plus 8i. And if this is one of our zeros, then that means automatically its conjugate is also one of our zeros because these always come in pairs if it's a 0. So there'll be x minus parentheses 5 minus 8i. Ooh, so this is what we have to multiply together. This is what we have to multiply together. So let's start working here. Let's go ahead and deal with these two first. All right, so let's get rid of the parentheses inside. So if we do that, it's x minus 5, a negative times plus 8i. Because this negative 1 is outside the parentheses. So negative 1 times everything inside. Negative 5, negative 8i. That's being multiplied by 8. And again, negative x negative 5. Negative times a negative this time plus 8i. And then we still have the other two factors out front. Okay, so we've simplified this a little bit. Let's go ahead and multiply these together. These are the nasty looking ones with the eyes in there, right? So let's distribute. Remember, these are still out front. We have to distribute 3 times, and we have 3 things to distribute. So we're going to have 9 things listed across here. X times x is x squared. X times negative 5, negative 5x. X times 8i plus 8i x. Tell you what, let's do this on a bigger sheet of paper. I don't want to write so small you can't see what I'm doing here. So x times x was x squared. X times negative 5 is negative 5x. X times 8i is 8ix. Okay, that was the first term. Now distributing the negative 5 to all 3 of those. So negative 5x, negative 5 times negative 5 is plus 25. And negative 5 times 8i is negative 40i. All right, still with me? Now we have to distribute the negative 8 times all 3 of those terms. So negative 8ix, negative 40i, and let's see, negative 8i times positive 8i is a negative 64i squared. All right, this negative 8i times negative 5 would be a positive. Because negative times a negative, that's going to be a positive 40i. All right, let's simplify what we can. There's only 1x squared. There's only 1x squared. Let's see, x terms. We have some real x terms, and we have some imaginary x terms. So real x terms are right here, negative 5x, negative 5x. So we have negative 10x. Then we have the imaginary term. So we've got this positive 8ix, and we have a negative 8ix. So those are going to cancel each other out. So those go away. What else we have? We also have 2i terms, negative 40i and plus 40i. Those are going to cancel each other out. So all we're left with is the 25 and the negative 64i squared. I squared is negative 1, right? So negative 1 times that is a positive 64. So now we got plus 25 plus 64. So this simplifies to x squared minus 10x plus 89. All right, so let's transfer that over here. All right, so this all becomes x squared minus 10x plus 89. And now we can multiply that by our other factors, x plus 14 and x minus 4. This just tells you when you do this test, you might want to have some paper handy because doing this in your head would be a real booger, right? All right. Let's go ahead and distribute. We need to multiply these together or distribute this over here this direction. And let's go ahead and put these together. Why not? X times x is x squared. X times 14 is 14x. Negative 4 times x is negative 4x. Negative 4 times 14 is negative 56. So these are like terms. So this becomes x squared plus 10x minus 56 multiplied by x squared minus 10x plus 89. Okay, now I have to multiply these two trinomials together and we'll be done. So we're going to bring back our extra work paper. I'm going to fold that under just because we're out of room on our sheet here before we get to the next problem. So we have three things to distribute to three different terms. So this is, again, along with x squared times x squared is x to the fourth. Okay, x squared times negative 10x, negative 10x to the third. X squared times 89, both positive, 89x squared. All right, now let's take the 10x times all three. 10x times x squared is a positive 10x to the third. 10x times negative 10x, now we've got negative 100x squared. 10x times 89 plus 890x. All right, now the negative 56. Negative 56x squared. Negative 56 times negative 10x is a positive 560x. And negative 56 times 89. Pull out the old trusty calculator again on that. Negative 56 times 89 is negative 4984. Okay, still ran out of room. Started way over at the side, still ran out of room before I got to the end of that one. All right, let's see if we can't put all of this together. I'll check and make sure I haven't made mistakes somewhere along the way. Let's see. So this is x to the fourth. There's only one of those. 10x to the third and a negative 10x to the third. That's the only x. There's no x to the third term. How about x squared term? There's an 89x squared, a negative 100, and a negative 56. So if we have negative 100 and positive 89, that's negative 11x squared. And negative 11 with this negative 56 is negative 67x squared. Okay, so that takes care of, we've done those terms. We've done the x fourth. We've done this squared, and this squared to combine them. We have two x terms, so 890 plus 560, so that's 1450x. Okay, and then we just have the constant, 4984. Final answer. That is the lowest degree polynomial that has these four zeros. Let's see if we have one that matches. X squared minus 678 plus 1450x minus 4984. Hey, what do you know? The answer we did even shows up on the list, so that's encouraging. A lot of work there, guys. A lot of work. Took a lot to get there, but we got there. All right. Oh, here's a good one. State how many imaginary and real zeros this function has, and they want it broken out. So we know that the Descartes rule tells us that the number of sign changes is how many positive roots there are. So positive roots, real roots, right? Real roots, positive roots. How many can there be? Positive, 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 positive. There are no sign changes. So there's no possible real roots on this. Okay, negative roots. To find negative roots, we substitute negative x, right? So negative x. So everything that's odd, like x to the fifth, when you substitute negative x times negative x 5 times will end up a negative. So that'll be a negative x to the fifth. Even number of times, negative x times negative x is a positive, and another negative x times negative positive. So you end up with a positive there. So that stays a positive after substituting negative x in there. Again, this one's a negative, so that's going to end up negative 2x to the third. And then we substitute negative x in there. Negative x squared is a positive x squared. So that's back to a positive. Substitute negative x there. It's just negative x and then plus 7. So how many sign changes do we have? From a negative to a positive, there's one. From positive to a negative, there's one. Negative to a positive, there's one. Positive to a negative, there's one. Negative to a positive. All right, so there are 1, 2, 3, 4, 5 negative roots. This Descartes' rule says there could be 5 or multiples of 2 less. Could be 3, could be 1. Okay, this is a 5th degree. So the fundamental rule of algebra says there are 5 roots. And all of these add up to 5. So we know that this is all there should be a right answer in here. Now, how do we know? Okay, we've ruled out positive roots. How do we know how to rule that down? Is there 5? Is there 3? Is there 1 negative root? Well, the other thing we know is we know all the possible roots. Factors of 7 divided by factors of 1. All right, so 1 times 1 and 7 is the only factors there are. And on the bottom is just 1. So the only possible roots is plus or minus 1 or plus or minus 7, right? That's the only possible real roots using what else we know, right? So if this is the only possible real roots and the positive ones are gone, the only roots there could be is -1 or -7. That's all that's possible based on what we know. So that means there cannot be 5 roots. We can rule out that. And there cannot be 3 negative roots because there's not 3 that are possible. So it has to be, by process of elimination, 1 negative real root. 1 negative real root, which means the other 4 are all imaginary. Other 4 are all imaginary. Like how we did that without having to factor, without having to figure out any roots. All we have to do is figure out what's possible. And this tells us what's possible as far as plus or minus. And we know to fill in the rest of the complex. Now, we can actually look at the graph of that. If we look at the graph of that, it will show us right there. The red, take off the red graph, put the red graph on. Look at that. There is only 1. It's at -7. -7 is, like, scroll out. You see it doesn't have any other roots. -7 is the only real root. So the other 4 are imaginary. So kind of cool. Confirm that by graphing, but we were able to figure that out algebraically right here, just using Descartes and fundamental rule and being able to know what possible zeros there are. Saved us a lot of work that way. Didn't take nearly as much work as this one up here did. All right, let's continue on. Write a linear factorization of the function. So they want us to factor this. Oh, let me get all the way down where you can see it. Factor this. All right, so the first thing we see is we can factor it by factoring an x squared out, and that leaves x squared plus 16, right? Okay, well, we need to factor that further because we don't have that as an option yet. We haven't factored it. So if it's x squared plus 16 as a factor, right, so what does that leave if this is equal to 0, all right, because when we have it equal to 0, if x squared plus 16 was equal to 0, we subtract 16. That means x squared is -16. So when you take the square root to get back to just x, that means it's a plus or minus situation. X equals plus or minus the square root of -16. Well, now we're in imaginary number country, right? So that would be 4i, plus or minus 4i. So if that's what the imaginary roots are, then those factors would be x plus 4i and x minus 4i. So that's what we put instead of that. So x squared, x plus 4i, x minus 4i is the factors of this right here. And we see that right there. X squared, x plus 4i, x minus 4i. There you go. That is the linear factors of that function. All right, using this given 0, find one other 0. So we're like, wow, so we know we could factor that and figure out all the possible factors. And we could do the Descartes to figure out positive one. But here's the nice thing. It said I is a 0. Well, I is an imaginary number. So what we know immediately is imaginary numbers come in pairs if it's a 0 of a polynomial. So if I, which is the same as 0 plus 1i, right? If you want to write the complex number out, it's 0 plus 1. That means 0 minus 1i is the other factor, which this simplifies to just be -i, right? negative I is our other factor. If that's a 0, that's a 0. Don't have to do a lot of work on that. Complex zeros come in pairs. All right, state the domain. So that's all the possible x's of this rational function. Well, we know the denominator cannot be 0. Now let it have a 0 denominator. So 14 minus x, what would make that a 0? If we subtract 14, that means negative x equals negative 14 divided by negative 1. X can't be 14. If x is 14, then this equals 0. So it can be anything else. So we can have a positive or negative denominator. That's fine. But all real numbers except for 14. It's fine if it's negative 14, because 14 minus negative 14 would make it a 28, because you would add since you're subtracting a negative. So that's fine to have negative 14. We just cannot have positive 14. All right, we just got a few left. State the vertical asymptote. Vertical asymptote. Well, the vertical asymptote is everything that makes the denominator 0. X squared minus 4 equals 0. So add 4. X squared equals 4. So if we take the square root of that, x would be plus or minus 2. 2 vertical asymptotes. Everywhere the denominator is 0 is a vertical asymptote. So x equals 2 or negative 2. Okay, don't make that harder than it is. Just find what makes that 0. Set that equal to 0 and solve. And don't forget, if you take a square root, you have a plus and a negative. We have a positive and negative answer. All right, state the horizontal asymptote. All right, remember to find horizontal asymptotes. First, we have to check to see what is the highest degree term in the numerator and the denominator. Okay, well, in this one, the numerator is first degree and the denominator is second degree. And so since the denominator is larger, y equals 0 is the horizontal asymptote. Doesn't matter how much larger. This could be x to the 5th, and still it's y equals 0 is a horizontal asymptote because that's larger. All right, now let's find the horizontal asymptote of this function. Okay, this one has an x squared on top and an x on bottom as the largest term. So that's a second degree term in the numerator and a first degree term down here. In that case, there are no horizontal asymptotes. Does not exist if the larger term is in the numerator. Okay. Oh, last question. Oh, and this is the other case. Give an example of a rational function has a horizontal asymptote of y equals 2/9. 2/9. Okay, well, let me write in function notation. F of x equals, and I'm going to have some fun with this, 2 times x to the 21st power plus 9x to the 11th power minus 7x squared plus 1 over 9x to the 21st power minus 3x to the 9th power plus 2x to the 4th minus x plus 2. And that all has a horizontal asymptote at 2/9. How do we know that? Oh, it's very simply because the largest term has exactly the same degree. They're both 21st degree terms. So in that case, you just take their coefficients, set them up as a fraction over each other, the numerator over denominator, and that is the horizontal asymptote. I could have simply just said f of x equals 2x over 9x. All right, doesn't matter, or 2x squared or 9x squared. Whatever, as long as the highest term is the same degree. So I was just having some fun up here because everything here did not matter. None of this mattered what I put over here, as long as it wasn't bigger than the 21st power. I have to make sure the biggest power is equal. They're both the same. And that would be a horizontal asymptote of 2/9. So whatever you want on there. Lots of freedom. Answer that like you like. So okay, that's it. 20 questions on the practice test. If you have any problems with any of that, please get with me before you take the test. Make sure you understand this. has some pencil and paper. Some of these, there's a lot to work through. You saw that one problem took a lot of paper. So you got to go through there carefully. Try not to make those little mistakes. And that'll help you. All right. Well, do work you can be proud of. We'll see you in class.
Let's get out of here. Word to your multiples.
Math, baby.